Good afternoon, everybody. You are at the SIG Azure Deep Dive. My name is Lachlan Evenson. Stephen sends his apologies. He's actually stuck in traffic, so he may appear in several minutes. He may not, but he should be here later today. So I'm the guy down the bottom. Stephen's the guy at the top. I'm a principal PM at Microsoft. I work on upstream projects such as Kubernetes, container runtimes, Helm, Draft, Brigade, SMI, a whole bunch of different things. So if you have any upstream questions or open source questions, come and see me. I'm also a release lead shadow for 1.15, so if you want any juicy goss on the 1.15 release of Kubernetes, come and see me after the show. And I'm an ambassador for the CNCF. Okay, I assume everybody here knows about SIG Azure or is participating in SIG Azure. I occasionally show up, and Stephen is actually one of the chairs, and one of the other chairs is Dave Strebel, and he sends his apologies as well, and has asked me to step in. I like to keep these things interactive, and I knew it was the last day, so I figured I would just show some innovation in open source that's happening around the Azure platform, different projects that are happening, how they work, give you a quick run through, and then we can take any questions. Does that sound okay? So what I've got up there is Cluster API Provider Azure. Who's your Cluster API user? None? Okay. Soon? Okay. Have you played with so you haven't probably played with the Azure Cluster API Provider? Okay, so I'll show you how that works. Okay, secret store CSI Driver. Anybody use this? You want to get secrets from Key Vault into a pod without having them on disk? I'll show you how to do that. Okay, and that's pluggable. We can also do it with HashiCorp Vault, or you could write your own, if you have your own back-end secret store, you can do that with CSI directly. AAD, pod identity. So we're going to take a look at how that works in context of how you can use Azure Active Directory service accounts to create service identities for your pods, and how that works. So I'll step through an example there. And then finally, I'm not sure if you're aware, but you can actually run Kubernetes as an etcd API for Cosmos DB. And I'm going to show you how to wire that up. Take a look at that. And if folks are interested, they could try that. Something we're very interested in getting feedback on. But that would take all the burden out of running an etcd cluster, should you have one now. And we're looking to solve other problems by doing that as well. Any questions? Is that okay? Interesting? Okay. So, Cluster API Provider. So what is Cluster API? It's around having a declarative interface API to build your actual clusters, right? And the way that works is with the Azure API Provider. I'll show you, I'll pop over to this link in just a second, is we, how about I just pop over it to now? Because I'll pull up the declaration on the screen here, and my apologies from going back and forward here. Can everybody see this? That, maybe? So this is a cluster definition using Cluster API for a Kubernetes cluster on Azure, right? So you can see here that we've got some CIDR blocks for both the cluster network and the pods, a service domain, and we've got down there a provider spec. So what location I want to work in, and what kind I'm using under the hood. So if you pop over to, I'm just going to show you where this is. This is under Kubernetes SIG's Cluster API Provider for Azure. So if you go take a look here, you just go in here, grab the release. Stephen works on this. We're at 0.1.0, so it's at try it. Let us know how it goes. But I can assure you that it does actually land you a cluster. And from here, I just want to show everybody where they would need to go to start playing with this. There's actually the install guide here. So we can go to the install guide, and we go to getting started. So basically, that's what I'm going to go through with you now on setting up an environment. And before I do that, I'm just going to turn on Docker for Mac, because it does actually load a cluster locally to actually build the other cluster. Right? So it's very interesting under the hood. To build a cluster, you need a cluster, because basically it's a controller with a custom resource, and Azure cloud provider plugged into it that goes and talks to the Azure APIs to provision another cluster. So that's an interesting tidbit about cluster APIs. You need a cluster to build a cluster. So just keep that in mind when you're actually doing that. So you need subscription ID, tenant ID, client ID, and the secret. You grab the tarball. You can set up, basically you can export some different variables here, and you run this generate YAML script. And what that'll do is generate all the contents that you see in here. So you have basically specifications for everything, from add-ons, which I'm just showing you there briefly, deployments, machines is interesting, so you can actually see from this thing that I've generated, I'm generating a 113.4 cluster on standard B2MS instances with a specific version. So everything's generated in APIs, what machines, what size of the cluster, how it operates. So it's nice if you want to come from that declarative background here, you can configure everything straight out of the box here. So I'm going to give this a shot. So all I've done is check that out, run through those details, exported those variables that I have already in my shell, and now I can just run this cluster CTL create. This is a log level. The bootstrap type is kind. So this is say, build me a kind cluster locally, Docker and Docker. Is anybody familiar with kind? Kind is a project under Kubernetes which runs Kubernetes in Docker. So you can run a Kubernetes cluster locally on your machine. Very similar to like Minikube. It's just a different provisioning mechanism. So that's the bootstrapper I'm going to use. I'm going to tell it to use the provider Azure, and I'm going to feed in these different machines, cluster, provider components, and the add-ons there. I'm going to go and run this. I'll pop the font here, and everybody can... Where did I put them? So you export them to your shell, right? And then they get interpolated. I had them up on screen here just a second ago. So you actually just put them as environment variables. Yep. Hello, Stephen. You can get mic'd up if you'd like to come on down. We're just going to kick off a cluster. They might be able to mic you up. Stephen's coming in now, but I'll just go through the rest of this demo here. Wonderful. Okay, so I'm not in the right directory here. Okay. I'm one directory up too high. So I'm going to just kick this provision off. It's going to go in the background while we're talking, and I'll continue to move on. But we were just talking about cluster API. Do you want to throw anything in? We were actually just gone through kicking off a cluster build with using cluster API provider for Azure. Yeah, so sure. Welcome, Stephen. Thanks for getting here. So yeah, Stephen's actually maintaining this project. So you want to add anything? We've kind of gone through it.
Did you go through the genesis of the project?
No, I have not gone through the genesis.
Okay.
I've just gone through building a cluster, which I can leave on screen while you're talking.
Okay, so real quick, I think so cluster API is a really interesting opportunity to start to consider building applications in Kubernetes in kind of a more meta way. So if you've heard of the operator pattern, it's very similar to building a CRD, but it's building a CRD that works for a Kubernetes cluster, right? So if you were to ask the question, in a world where I could build Kubernetes using Kubernetes, cluster API is the answer, right? So what's happening on the screen right now, actually, is we're running through the cluster instantiation process, right? So there are two primary resources within cluster API, and it's the cluster object and the machine object, right? So we're in the process of creating all of the bits and pieces that need to be created for an Azure cluster to exist, right? So in future in the project, we'll see things like Bastion hosts come up and different configurations for load balancers. But right now, it's a public load balancer, a private load balancer for the master, and a single node, right? So you can configure that based on a YAML file the same way you would do anything else in Kubernetes. And I think it's pretty cool. So like the genesis of the project, there was an intern, and his name is escaping me at the moment, from Platform 9 who initially started working on this. and then kind of tag teamed with another intern at Microsoft. And after that, I was kind of looking around and I was like, okay, cluster API is the next thing that we have to get into on SIG Azure side. So I reached out to them and said like, hey, let's get this started. Let's get this migrated as a Kubernetes repo. And since then, it's been myself as a primary maintainer. A few of the AKS engine engineers at Microsoft. So it's one of those things that's high priority for multiple companies, and it's nice to see this community effort kind of rallied behind it. So.
Yeah, fantastic. And while that was happening, I just pulled up on screen that this is actually the Kind cluster at the bottom, which has actually gone to provision that cluster API system namespace with the controller and the Azure Provider Controller Manager. Now what that's doing is interpreting that declaration for the cluster and going out via ARM and provisioning all the components.
So Cluster API has like two essential steps, right? It's the bootstrapping step and then the pivot, right? So the bootstrapping step is exactly what Lachie described. We spin up a Kind cluster. You can use Kind or Minikube to do this. And what it'll do is spin up an entire Kubernetes cluster within your laptop or within whatever computer you're using, and spin up the Cluster API Controller Manager and the Cluster API or the Azure Cluster API Controller Manager. It's a mouthful, but and after that, did you have a question? Yeah, hold on. Sure.
So you kind of mentioned a minute ago about AKS Engine. So the result of this, is it an IaaS-based Kubernetes
Yes.
cluster, or would it be, so there's no kind of AKS option right now, it would be true IaaS?
Right.
Just to make
Right,
sure
so
I understand.
you'd end up with an IaaS-based cluster on Azure at the endpoint, at the end goal, and you can see this loop down the bottom, and don't worry about that error, it's retriable anyway. But what's going to happen is it's going to go through provision all the machines, and you'll end up with essentially the same outcome as AKS Engine, just using cluster API's definitions, rather than the definitions in AKS Engine.
Sure.
Question up the back? And then
What's the use case? Can you tell about a use case for this instead of using ARM templates or Terraform to deploy cluster?
Sure. So I think the use case, and Jason can, Stephen. I'm sorry, Stephen. Stephen can talk to it as well, but I think having a central point to distribute and maintain, there's also control loops that take care of day two. So AKS Engine at the moment has some day two operations, but the goal of Cluster API is to be a one-stop shop. You go and modify that file and update it. The control loops will actually go and implement the changes in your cluster. Yeah. So there's some day two lifecycle-y bits that Cluster API has goals to solve. So whilst we're just spinning up a brand new vanilla cluster, which AKS Engine can do as well, there are also control loops that are doing day two operations. So think of it like an operator to build Kubernetes clusters is the way I think about it.
So I think it's really important to understand that think about all the infrastructure that you've already built out to manage Kubernetes, right? So whether you're using Helm or Customize or things that are in random Git repos, the ability to tie the way you manage your Kubernetes clusters to the applications that get managed within your Kubernetes clusters is pretty powerful, right? So as Lachie mentioned, one of the big strategies of using Cluster API is that you get to manipulate this kind of control flow, right? This controller flow, where if I provide a spec, so there are two primary things that we look at, right? The spec and the status, right? Both for the cluster and the machine, right? So I provide a spec to Cluster API, and Lachie, I don't know if you want to pull that up, maybe.
Yeah, I can pull the spec. Yeah, sure.
Yeah. So the spec will. I'm trying to think if there's going to be anything sensitive in the spec.
Nope.
Okay. Awesome. So the spec over here, runs through the resource group, the location that you're going to create. So this is incredibly repeatable, right? And what happens, after I submit the spec to the cluster is that it reconciles it, right? It reconciles it, and then it writes a status to a management cluster. So so what I had mentioned before about there being two phases, there's a bootstrap phase that happens on your local machine or whatever machine you're using to provision Cluster API. And then there's a secondary phase called the pivot, right? And the pivot basically drains the nodes that have been instantiated or the clusters that have been instantiated within that local Bootstrap cluster and migrates it over to a management cluster. Now the whole management cluster idea starts to become really powerful because that means I can supply foo amount of specs to some management cluster and spin up cluster API Kubernetes clusters within Azure, within AWS, within OpenStack, right? So this is if I could manage Kubernetes in one singular place and have it work on multiple clouds. Now the multiple cloud support isn't there yet, but I think that's the dream for cluster API. So
Cool.
Yeah, so basically, if you want to, I think it might be happening soon.
Yeah, sure.
If you want to pull up the terminal.
Yeah, if I...
Or not.
What would you like me to show?
So within the cluster CTL command, so I think the top one is your...
In here?
Yeah.
Yeah.
It might not be happening yet then. Right, cluster creation complete, and then scroll down.
Scroll down. This one?
Yeah. Come on, pivot.
Keep going.
So essentially what the pivot, this might, depending on the verbosity of the logs, you might not be able to see some of it. But essentially what the pivot phase does is it scans for it does a list of all of the cluster API objects within a set of namespaces, right? So the namespace that you provide to the cluster API or cluster CTL, right, and the provider components. It will essentially list the objects that are in that. So the clusters, the machines sets, the machine deployments. So there's more work to be done on like the machine sets or machine deployments. But that's the same idea as like machines are analogous to a pod, and replica set is analogous to machine set, and machine deployments are analogous to deployments. Kubernetes objects, right? So, basically, after we do a list of each of those objects, the list is essentially pushed into another Kubernetes cluster, right? So as the pivot phase is happening, you're able to pull a kube config, right, for that management cluster that's out in Azure, right? And then from there, you authenticate and push those new objects in, right? And because it's because it's a controller, right, it checks to see if the objects are already there. And if they're there, it just reconciles the status of them, right? So it's not you're not recreating any objects after that initial bootstrap phase unless it's trying to reconcile some state like security groups or load balancer rules.
All the assets, yeah. All the assets to need to get the cluster bootstrapped, yeah. So I think the call to action around this out is if this is something that interests you, you can show up in the community, right? And you can take a look and play with this today and start to kick the tires, because cluster API, while we're showing it in the context of Azure, is a large movement to go across all the cloud providers and provide a new, unique day two operational experience that's more in line with how we are working with Kubernetes today to build Kubernetes clusters.
Yeah, so
anything else you want these people to know about cluster API?
Yeah. Additionally, I think that if you're interested in it, like Lachie mentioned, please try it out. I'm going to, I think once KubeCon dies down, I'll cut a 0.20 release of that has some improvements and kind of locks into the V0.11 version of Cluster API upstream. So after that, I want to start looking at starting a community meeting around Cluster API Azure. So if you're interested in that, those details will be available on the community website, github.com/community/SIG Azure. Right.
Cool. All right, we're going to move right on to secret source CSI Driver. So as most of you probably know, in 1.13, CSI became GA in upstream Kubernetes. So what we've built here, this is all open source as well, the link's down the bottom, is a secret store CSI driver. What it actually allows you to do is integrate secret stores into a Kubernetes volume, right? So think of this like I have secret certs or keys inside Key Vault, HashiCorp Vault, any kind of enterprise-grade secret store, and you can present them into pods via Kubernetes directly, right? So I'm going to show you a quick demo on how to do that. Now, this is This, you must have one, if you want to use the inline volume. Do people know what the CSI inline volumes are? I'll show you that quickly. Basically, you put all the details of where you want to pull the vault secret straight into a pod rather than into the PVC system. So rather than in, you can pull it straight in. It also works with pod identity as well. So I've got another slide on pod identity, but let's just kick the tires here and I'll show you how it actually works. In the interest of time, we'll do this nice and quick. Okay, so basically I'm just going to show you a pod spec here. The pod spec is no different to any other pod spec, and we have a volume mount down here called secret store inline, right? And we're going to mount that to mount secret store, read only true. Now here is the interesting bit. Basically, we have the contents of where the key vault is, whether we're going to use pod identity down there on line 22, what the key vault, what the object name, what the secret is, and where we want to mount that in. Right, so this does not get pulled to disk. It actually sits in memory on the node and then gets mounted in. Right, so this is a nice way not to have to store things like put your URL connection strings for your databases in Key Vault or something like that and pull them straight in. Right, so the net effect is I should be able to read a secret out of this mount secret stores. Right, so, okay, is that font large enough here? Okay. So I'm just going to show you, I have this cluster up and running now. So I actually have, you wouldn't have to install anything on the cluster apart from the CSI driver, which just runs as a daemon set in a different namespace. I have the Nginx secret store inline pod up and running. So I'm just going to simply do a kubectl exec. And I'll do an ls on, what was it, secret store? I think it was secret store.
Secret store inline.
Keep me honest here. And I should see that the name of this particular secret is there, so I should be able to just grab that, and I'll just go ahead and cat that. Right, so this is a test. I can read that. So you have it in a volume, you can manipulate it via Kubernetes directly. Did you have something, Stephen?
I was just going to say those are actually Locky's credentials. So.
Yeah, again, because I pulled my other credentials up earlier. So, okay, just one final. If your thing isn't having it inline, it'll also work with PVs and PVCs. So let me just show you. This would be the PV version of the same thing. So some people say, what's the difference between using inline and PV versus PV? That system. If you're a cluster admin and you know where a secret is, maybe dropping it at a PV is a great place to put it, so that developers can come and just put a claim, and multiple CODs can just claim that, put a claim on that volume where your secret is stored. But if you're building your own secrets as an application developer, you might just want to put it in your pod spec so you can mount them straight in and you know where that is. Because obviously you need to know details about what subscription it is, what name is. You can also add, you see line 20, it's an array of objects, so you can pull in individual objects. So certificates is a good one, right? So you're not generating certificates on your nodes, you generate them in something like Key Vault.
Yeah, so I think it's, it's a rather powerful model, because you're essentially able to abstract the need to understand where these secrets live away from the developers that might be using your applications, right?
Absolutely, yeah. We have a question. I can repeat it.
Let's get it on. Hold on.
Towards the flex volumes used to do.
Yeah, so flex volumes is the old way. We've implemented the same functionality under CSI. So if you're familiar with flex volumes and you're prior to 1.13, flex volumes is actually, we've developed that a lot more than the CSI. But everybody, is rallying towards CSI, so we wanted to take the opportunity to migrate it over to show you what the experience could be. So if you want the inline stuff, it's actually only in the 1.15 beta, and you need to have a flag on your controllers. So, but feel free to go. I'll just pull up the slides here again, and these will be shared. Obviously, you can go and kick the tires. You just need a cluster. It doesn't even have to be running on Azure. You can go and grab those secrets. Yes, one more question?
Can you elaborate on the pod identity aspect?
Yeah.
What does that
Next slide.
Okay.
No worries. Here we go. Thank you. Let me get you that money now. Okay, so pod identity is around having, so at the moment, when you're running a workload on Kubernetes on Azure, without pod identity, the pod or the workload gets the identity of the node, right? Which means it has the access credentials to talk to the ARM APIs that are the same as the node, right? So in a multi-tenant cluster, you may not want that. So let's talk about using Azure Active Directory to push up identity into the pod level, right? And that's what this is about. So we've tied in Azure Active Directory services, and we can assign them to pods, and you would grant access to those service accounts to the different services. So the demo I just did was actually using managed identity. I was going to just unravel it a little bit. So basically that means I don't have to create a service principal that I would store on the cluster to read and access that key vault. It's using an identity. It's going down and pulling that identity live. So there's a bunch of operational things going on under the hood, but it means you don't have to use a service principal, right? You have dynamic identity coming off Azure Active Directory. Okay, so let me just go and unwrap that a little bit. And for those playing at home, you probably saw that there were a couple other pods here, and you were like, what's that got to do with the demo? So NMI, NMI and MIC, it's kind of cut off on the left-hand side, I'm sorry. But basically, there's a daemon set that deals with assigning the identities that you create. So I'm just going to show you the objects in Kubernetes that you need to create. But go and install pod identity, and you'll end up with these 4 workloads on your machine, 1 per node. These ones are 1 per node, they're a daemon set, and then the managed identity controller is there as well. But this should just work out of the box. So what I'm going to show you here quickly is you will end up with a bunch of custom resources, right? Azure assigned identities, you don't touch that, so that's dynamically updated as statuses and identities are assigned. We have the Azure identities here and identity bindings. So there's only the top 3 that we're interested in. So I'm just going to get this and show you what that looks like. So because I only have 1, I didn't need to call it by name. But basically, here's where we reference the managed identity in which resource ID. But you can see there that I don't have any secrets associated with that. That's just a managed identity that I have access to call. Now, I want to bind this identity to a pod, right? So I'm going to go back, grab the CIDs. I'll show you the bindings. So Azure identity bindings. Actually, I'll just run this last command again just to show you the name of the identities that I have, which is this secrets demo that I'm running now. I'm now going to show you the binding. And if you take a look here, basically I select the identity that I was just created. So I created an identity and I called it CSI-secrets-demo. And I want to use a label selector to actually select the pod to use that identity. So I give it an arbitrary label. I called it the same thing. It could have been called, foo. So basically, if I label a pod, and what you'll find here, so I'll go back to show you what pods I have running. If I go back to this pod, actually, why don't I just do this? Right, so as long as you have that key and you have the value of that binding that you created before, that pod will get selected to use that identity, right? So, and that identity under the hood, I've gone and allowed access to Key Vault so that I could actually read that secret out. So again, there's no service principals on my machine. There's no secrets. I don't have to worry about that game. And I'm using an identity for that workload, not inheriting the node's identity to access Azure. Does that make sense? Yes? Question? I'm going to keep going pretty fast because I've got some exciting other things to show too.
So any developer that knows that key can get that permission, let's say? So how do you control?
RBAC. Can you read that resource?
On the keyboard?
So no, on RBAC in Kubernetes. Yeah. So are you saying how do I stop somebody label selecting that thing? RBAC.
I just know that you have a magical label when you deploy stuff as a developer. If I were to do that, can you filter that out with policies or something?
Yeah, you can use Kubernetes role-based access control to say that you can't read the identity in a namespace. You can put the label on the pod, but if the user can't read that, because basically the user will go and read that pod, will go and read the identity, but you can lock it down with RBAC. I'll show you. I'll show you afterwards. Is that all right? So I can keep going. Okay, keep moving. Kubernetes on Cosmos. I'm going to do this real quick. Cosmos DB, etcd API.
So I think if you attended the Seattle KubeCon sessions, Cal also did
it, yeah.
A demo on this one.
So I was going to show you this like super quick, if you're interested. So you would just go to, I will just show you a cluster that I already have created in this, and I'll bump the font here. And so it's super quick. If you go use, you basically get an Azure Cosmos DB. So the interesting thing is here, you just point, you don't have to reconfigure Kubernetes at all. You just have to point it at the endpoint that's created with the etcd API, and then you can actually go in and, I think I look at Document Explorer here, Data Explorer. I can actually go in and introspect what objects are in there in the etcd data.
If I remember correctly, the configuration is just a flag, right, within the...
It's a flag within AKS Engine to do it, but let's say it's just a drop-in replacement. It's all wire protocol of etcd. You don't have to do anything to Kubernetes. Run stock Kubernetes, point it at this endpoint, it'll work. Okay?
What's the advantages of using Cosmos DB for like resiliency, failover? Is that?
Yeah, resiliency, failover, read-write latency, but I'd say that's subsidiary to not having to manage etcd.
Yeah.
So growth and scale. So as your Kubernetes cluster grows, you're probably familiar. You have to go grow your etcd cluster on the back end appropriately to make sure it's meeting the demands of the API server. So not having to do that and scale that up and getting the monitoring as well for how hard that API is being hit out of the box. So this is not net new. We pioneered this, as Stephen said, at Seattle, but other providers are doing this too.
And I think it's interesting to see that, you know, etcd has long been the brains of Kubernetes, right? So it's always been like, here are your recommendations for etcd, and make sure you either, like if you're doing stacked, you have to do it a certain way, and if you're managing it yourself or someone else is managing it, you have to look after etcd. So it's nice to see improvements around ensuring resiliency in the brains of Kubernetes via these managed services.
Go for it.
And inversely, K3S using SQLite as the backend. It's the same trick, just the inverse, using it on a lightweight system.
Right.
Really cool.
Yep, absolutely. So finally, I just wanted to call out some work that's going on within Azure as well, and this is dual stack. It's happening upstream. So what is this? Enabling dual stack workloads inside Kubernetes, IPv4, IPv6. We're also enabling multi-interface pods at the same time. So you could have NFV, IPv4, 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 IPv6. So getting that work started, the main reason I want to call this out is if anybody's interested, we need help with reviewing the PRs and we need help with playing with it, right? And if you have this use case where I can't use Kubernetes until it has dual stack, we're working on it actively. So the call to action here is really, we're trying to do this. We have a KEP merged. It's going to be a multi-release process that's kicking off in 1.15. If you want to check out the KEP, go check out the KEP. The pull request is there. But if you're interested, find Stephen or myself and we can connect you to the right people to help us actually drive that through if you're interested in dual stack.
So I think we're hitting like pod ciders for the first.
Yeah, pod ciders, multiple pod ciders.
And we know that it's working at this point, right? So I think there's been a lot of work in essentially. This has been something that's been requested since maybe the dawn of Kubernetes, but more recently probably since like 1.9, 1.10. Right, so to see this work actually landing is huge. And it's huge to people who are dealing in these dual stack environments. So.
Fantastic. So how can you help? Obviously, this is all on the auspices of SIG Azure. So you feel free to come into SIG Azure. We've got the meetings up there. Stephen is one of the co-chairs and Dave Strebel. If you've never joined, feel free to join. We welcome you. Give us feedback and help us prioritize things that are and aren't working and things that you are and aren't interested in. And that's a good venue to do that. Feel free to come and talk to us afterwards as well. Anything else? Yeah, no? Okay, so well, I think we have 1 minute for questions. Perfect. Photo finish. Yes.
Oh, so close.
Regarding pod identity?
Yeah.
That's an Azure thing,
Yes.
right? Is there anything in the works with regarding standardization across Kubernetes?
Yeah,
Like
so
SPIFFE, etc.
Yeah, no, absolutely. So we were looking to see if we could land kind of the concept of how it would work, and then we would be welcome to see if we could pick it up with other providers as well. But other providers, we need to somehow come together and figure out what that means, because I know this is something everybody wants on every provider, and how to do that, whether it's via SPIFFE or something else, would be really interested. So if you have any power or from another provider and you're interested in doing that, please come and see me. Any other questions? General feedback, did everybody learn something? Got something to play with when you go home tonight? Fantastic. Well, thanks for joining us.
Thank you for coming.
We'll hang around a little outside if you have any other questions.